Hi, in this video tutorial, we will use the expert analytics to perform time series analysis, just like we did using the time series with automated analytics. The expert analytics is a very sophisticated mode of operation, and here you can bring in data from different data sources, including HANA, and you also have access to, if you have a HANA access, then you have access to HANA's PAL libraries. PAL libraries are efficient algorithms that was implemented in memory natively within HANA. So you can have multi-million records easily computed in HANA itself, and then the result can be delivered and you can visualize here. This is a trial version, and I don't have HANA, so I'm going to use to demonstrate time series analysis using a CSV file. Um, if you have ever used Lumira, it looks almost Lumira. You can see the visual feel of it. It is a kind of a map. What exactly step by step you got to do. You have acquire data, and then you can combine data with other data. You can do a calculated columns here, filter, and then you can bring in kind of a data flow type thing. You take your data widget, you have a filter widget, and then you finally pass it to some kind of predictive methods, algorithms, and you configure each of these widget and kind of a data piped across, and you find the result at the end. For our time series analysis, we'll use the same data, but we'll do some small slight modifications. Here, let's estimate prediction for on a quarterly basis for a couple of quarters, apart from what the data set provides. And also, we noticed some outliers visually. Let's use some kind of filtering method to remove outliers in sales data, and use available time series algorithm to do some kind of forecasting. So the first step is to acquire data, and I have this file as a a CSV file. So you can go ahead and load it. Um, in this case, what are files you might have? The data is the same as the previous um, expert analytics, automated analytics look and feel. So you have stores, day of week. Store is basically a dummy. You need not even bring it, so you can say I don't want that. Day of week, you have a date, you have sales and customers. Both of them are target variables that we want to predict, and you also have some flags. One thing you want to quickly make sure is your date is in the format that you want. When you click advanced, it provides options to indicate what your format of date is. Here it's YYYMMDD, so I'm going to select that. Here you go. And I'm going to first create a data set. So what this does is it brings the data into expert analytics platform, and here you can visually look at the data, what it means, and you can go do additional matchups of your data and prepare. So we will jump onto looking at the data in preparation. So here you can do additional calculated dimension if you need. There's a calculated measure. There's a bunch of functions by default SAP supplies. You can use them to create, for example, you want to know month from the date, or you want to know the day of the week, etc., you can also calculate here. We already have pre-calculated that and brought it in. So our goal is to load this data, and to do that, I mentioned about widgets. So this is our starting point of the data that we brought in. We didn't do any additional calculated column, anything here. We just brought the data from an Excel, from a CSV file. Our intention is to remove outliers that kind of influenced that we don't want to use it for calculation purposes. So let's look at a few steps here. We also have zero value data. When you do exponential smoothing, you want non-zero values to get a good fit. And we also want to predict this not at a day level, we want to do it at a quarterly level. So first I'm going to do a filter. So in the data preparation, so on your right hand side, there's all available methods, algorithms are shown here. It's like a simple drag and drop, and every time you drag and drop, these widgets or containers kind of has specific filters that you can enable or include parameters to it, and that will influence how the algorithm is going to work. If you have a HANA PAL library access, when we brought in the data, if you have the HANA credentials, this will show additional HANA PAL algorithms available, and you should be able to use that in this case, I'm going to use that triple exponential smoothing for the forecast. HANA has its forecast algorithm also. One of them is the triple exponential. And let's filter the data first, and then we will use outlier detection methods, IQR, for removing sales that are too spurious or too high. So first drag and drop the filter. When you drag and drop, it creates an arrow. This is basically how the data flow happens from this widget to the next widget. So I'm going to configure the filter. So basically what I want to do is I want to filter out any rows that has a zero sales. If you remember, there are some holidays and there's zero values to it. So I'm going to click greater than 0. If you have zero values, generally the exponential smoothing methods don't behave so good. So and I'm going to keep all other rows, all other columns. I'm going to put done, and I'm going to bring in a way to filter out the outliers as we discussed before. So I'm going to use IQR, interquartile range. So interquartile range basically removes any extreme values based on looking at the quartile ranges. Keeps the data within the interquartiles, and any extreme tails it will remove. So here I'm going to leave the defense coefficient 1.5 as it is, and the feature that you want to use for removing outliers is sales. Then finally we're going to bring in triple exponential smoothing. So this is a very straightforward time series analysis algorithm where you kind of want to remove or you want to include trend and seasonalities over a period. So the coefficients alpha, beta, gamma are already provided here, but you can also, if you have access to a library, you will be able to use an optimal optimizer there to get a optimal values for alpha, beta, gamma, because this influences how good fit you're going to get also. So here we will do a forecast, and as I mentioned, we'll rather than days, we will do quarters. So I'm going to do predict for 2 quarters with the target variable of sales, and the we're going to use the date, which is the date column, and we're going to indicate the period we want to have is bug. The trial version sometimes buggy. You may not see that drop-down box appearing. You just need to close and reopen the work. So here I'm going to do a forecast for 2 quarters, and my target variable is going to be sales, sales units, and I'm going to use the date column, and I'm going to aggregate this date, which is day level, into some kind of a quarter, and then use that as a predictor. So once I'm done, I have a full flow of information from here, from my data, kind of filter it out. I remove any extreme values, and then I'm applying a triple exponential smoothing algorithm. So once you're ready, you can click run. It takes few seconds because not a large amount of data. So it kind of executes and produces reports, results. So here is the data. So what it did is it kind of got the sales, and if you know a little bit about the exponential algorithm, it kind of uses kind of a moving average with the trend analysis and seasonality analysis. So it won't generally provide any predictive for the 4 quarters, because the level we are requesting is at a quarterly level. What it did is this is the actual sales data, kind of aggregated over quarters, and this is the actual predicted values that kind of came out of the algorithm. And you can look at how the trend looks like, etc. Using that visuals that is available in the trend chart. And at each widgets, all the outputs at every level can be analyzed using this option. But for now, we are looking at the end value, which is the actual versus predicted for the sales over different quarters. So you can see that kind of a tight prediction. It's pretty doing a good job. And now the forecast is actually saying, this is how the new prediction is going to look like. You can look at some of our performance metrics. There is a mean absolute MAP, which we discussed previously. This is actually expressed as percentage. It's 3%, which is pretty tight and very good. But you can, ideally you should be able to get the alpha, beta, gamma values optimized, but the system provided value we just used here for simplicity's sake. So this is how the forecast kind of provided, and you can play with your own data. So thank you for watching the video.